So yeah, I sent out the Canvas announcement, but our quiz will be Thursday, and it will have you making a Slurm header.
Not a Slurm job, just the header.
Just the header, yeah. And like a hello world job. Yeah. Um, and then this assignment, well, the assignment for the lesson that we're doing now, I'm not going to even assign it until next Thursday because there's no way we're going to have a lesson done for that. And I want to make sure that all of us are like able to kind of run this pipeline, this metagenome assembly stuff before I give you the assignment, which will be do it a bunch of times. So changing the settings and comparing the outcomes. But don't worry about that yet. We're going to kind of focus on just making sure we kind of get a feel for this pipeline. Yes.
You know, when that would, maybe we do, we have like the next week is like the Thanksgiving break.
2 weeks after Thanksgiving.
So the final,
So we have 2 weeks on next Thursday.
Yeah.
so it's due to the last week.
Mm-hmm. You know how in the syllabus there's like those last 2 or 3 weeks that's discussion time? Mm-hmm. That's because I knew this would take forever. So I built in that flex time. I'm so proud of myself for thinking of that because yeah, we're gonna need it all. Get this done.
What's like the timeline for like the group projects and stuff like that?
Let's just say I cannot see them happening on the semester timeline.
Is there anything else that like let's get our grades up or?
I'm not gonna just give you zeros.
We're just like, it's
For
gonna
that.
be like 50 quiz, 50 assignment.
The only thing I could think of doing, and I don't know if I want to do this. See what you guys think, is make assignment 8 the group project.
That would be true.
Because you could, that way you could like split it up, like, you know, 2 to 4 people or whatever can like divide it up. That I'll run this version of pipeline over that one. There.
So I just feel like we should go around and then talk about it.
And compare the results. Which that's what the group project is essentially going to be in the end anyway, is making a pipeline. Because like you saw when we looked at the branching exponential bullshit of how this can go, that we have like 30 million different ways of running the same pipeline. For the group projects, I was hoping that you would do like a few of them intelligently chosen, like don't just change the output file name, but like change one of the important settings and kind of see how that affects things. And so assignment 8 was supposed to kind of prep you for that, but I think given the way things have been going, maybe assignment 8 is the group project. Also, what do you feel?
I just want something to like go with the quiz. That's
To balance out the quizzes. Yeah. No, y'all get a 0 on the group assignment because like nobody would ever take this class again. Well, let's pencil that in like as probably the best way of getting the group project worked in. It's assignment 8. If anyone objects, let me know and I'll let you do it on your own. But all right, so where were we? Did anyone else have trouble with the like download script? Still having trouble? Well, at least it's doing the right metaphor. See, it says just so it's- Probably should.
It's so classic.
Figure it out later. Okay, so for Arthi, sorry. You've got a previously installed BioPython, an old version, and that was like blocking the installation of Metaflam. And now something else. Yeah. Let me just start sorting. Yeah. But essentially, this script was just to get us Metaflan and Proca. But we don't need to use those today, so it's okay. And to install their databases. Because if you remember our like pipeline here, we've got the stuff to do quality control, right? That's FAST-P. Assembly, that'll be spades. And then Metaflan is for this part, the like phylogenetic assignment, short reads. And then Proca is this part, finding open reading frames, identifying and annotating the genes context. But we won't get to that today, so it's okay. Yes,
Sorry for interrupting.
No worries.
Are you recording?
yes,
Okay.
let me double check. Yes, recorded.
I just have like a quick question about the downloads, like when we obviously like downloading Metaflam like took a while and it has like in the Metaflam like database folder, there's like a bunch of different
Bunch of different stuff.
files. How come in Broker there isn't anything? Is there like a reason? Is it just like how we access the database?
Yeah, let me get logged in here. Proca, I tried to make it go into the Scratch directory and it wasn't working. Well, it seems like Proca really wants to put its databases in its own directory where it's installed. So let me get Conda all set up. I'll do 11.43. Those 2 comments. And then this here is, I had some of my code in GPT, remember where it was like, find it and run the Conda shell? And it was like, you're an idiot, you could do it this way. And that is much nicer to type, so that's what I'm gonna do now. Okay, so that's great, but I also noticed that it does put me into a base Conda environment when I do that. But just to note, so I can do Conda activate,
It's that one.
thank you, Coda. That activate. Proca environment. Okay, there we go. Which Proca, alright, so it's in my home. Conda, this is the magical spot where all your Conda environments live. And then it's got my environments, Proca environment, and okay, so if I go to this directory. And look around, it made a DB folder.
Mm.
That's where they all are.
Okay, so I still remember what you said that you module for 3 and then you do. Just the eval. And then on the. Okay, so then, basically, like, when we're like using the script instead of go there, instead of going to our like scratch and.
Right, and so I try to make it go to scratch 10 and. There's bound to be some way of doing it, but it's not easy, and so, okay. What I don't like about this is that. This is kind of a big folder. Full of a lot of stuff. Look at all this.
Also, how do we get over the base? You have to do credit, you have to do twice.
Yeah, you gotta do it twice. So it's 607 megabytes for the Proca databases. That's not huge, but I wish that I could put it in Scratch, and so maybe someday I'll go in and figure out how, but it's not big enough to where I'm super worried.
So there's like technically nothing broken in our scratched, but we just have the folder for like, it's there.
It's there,
Okay,
yeah. It was supposed to be populated with this stuff,
I see, okay.
Yeah.
So that's kind of like an old thing that we are using.
yeah.
Okay, cool.
On the deactivate. Back in base, Conda deactivate again to get out base, okay. All right, so what's left in our pipeline?
We could do the quality.
Yeah. Scripts. Quality control, we've done that one before. Nice and easy with FastP. I'm gonna let you do that on your own, not spend class time on it, but there I'm just setting up same directories I had from the previous script. FastP. There. Now I would want to do this in a for loop. Ideally, right? Where I take my input forward files, change them to 2.passkey.gz. So I'm making my input and my output files. And those are all going into my Scratch. There they are. So I've got my QC files. I just stuck them all in the same directory. Because why not? I just changed the name using parameter expansion to where to have a QC so I can easily loop through those later. Right. LL star QC star. Those.
So do you want us, like after class to write the script?
Yeah.
Do you want us to run it?
Yeah.
The login?
It can be run on the login node. Because it's just the one file and it takes like 1 minute to do QC on this. if you had 10 files, maybe make it a SARM script. So for the actual assignment. All right. So we're gonna do quality control, and then that's again really fast. It's like 1 minute per sample, so not a big deal. Next up is what? The actual assembly. So we're going to use a program called Spades for this. Has anyone got that installed yet? Beautiful. All right. Spades.py is how you call it. It's in your path. You can just run that and it gives you the, hey, you did this wrong, here's the help file. Okay, so spades.py, you give it some options, and then you must tell it an output directory. This output directory, it will create it on its own, and it has to be empty. If there's any files in it, Spade won't run because it doesn't want to overwrite anything. So we've got to give it an output directory. And then we can give it one of these basic option flags. What do we want?
Meta.
Meta. But look at all these neat options. If you've got an isolate, so like from cell culture or something, that's great. If you're doing single cell genomics, all these do is they change the way that Spades runs to be optimized for that type of data. But we definitely have metagenomic data. I see that they even have a sewage mode now. It's nice.
What are we doing, like the software Metaspace and like the meta version of Spade?
Metaspades is just an alias for spades dash dash meta.
There's no like, there's no.
There's no difference. So we can say metaspades.py, or we can say spades.py meta, and it's the same thing. Okay, and then what's it want?
Maybe I think insert one would be like the clean forward and
Exactly that. Clean forwards. And then the clean reverse. So we need a 1 and a 2. It gives us this S option if we only have forward reads, for example, or if we use Oxford Nanopore, you don't get forward and reverse reads with that technology. It's just single reads. So you say, hey, these are unpaired. You point it to a single file. We definitely have 2 files, and they're not interleaved. If they were, it lets us do dash dash 1 2 for that single file. We have merged forward and reverse reads. Some of our quality control stuff, BD map, for example, you can tell it to not only do the quality trimming and everything, but then merge the 2 things together so you can give it that input. Okay, so we're going to have to give it -1, -2, -0. And then all this is folder deprecated syntax. And then we can tell it whether we've got Sanger sequencing reads, PacBio, or Oxford Nanopore, which we don't, but it lets us do that. And then the pipeline options. These can come in handy. But by default, Spades will go in and correct your reads first. And this is kind of a compute intensive big step. It has to build this error profile, and then it runs some machine learning stuff to like decide whether that A really is an A, whether it was like mistranslated into something different by the machine. That can take a while. And so they give you this only assembler option. Like if you don't care, if you say like, I want to be rough and sloppy and just like do this, you can do only assembler. Or maybe you're only interested in the error correction step, so you could do that.
Is there one you usually do, or?
I usually let it do both. In my big marine mycology thing, I am skipping the error correction. So I have 5,000 samples. Each one is taking 3 days. So it's ridiculous. When I had the error correction running, they were all running out of time. But they're really huge metagenomes. They know that this will run out of time on most HPCs if you got a big file, and so they give you a continue option. So Spades makes little checkpoints along the way, and every time it finishes a little stage of its process, it caches all that, and so you can just say continue and give it that directory, pick up from where it left off again. So that can be kind of nice. It'll let you restart from one of these checkpoints. Right now, I think we can skip all these and let it do the defaults. Hopefully we don't run into problems where we have to continue. And then it lets us pick some advanced options that actually aren't that advanced, because it's things like how many threads you want to use. How many have we got? 4
It's 20.
20, yeah. So we want to set T to be 20. I'm going to ask for that much. And then it lets us set memory limits. This is to be safe on an HPC if you're running big files. What we've got is not too big. It's like 500 megabytes or something. So just let it go, and hopefully it doesn't run out of memory. But how much memory do we have on our standard Bora nodes? 128. Okay, so it's really hoping that you've got 250. So what do we do if 128 is not enough?
Continuous, when they don't continue.
Oh, you can't, because this is why genome assembly is so compute intensive. It's because you can't actually split the process up at all. Because it's trying to build those De Bruyne graphs of all the possible k-mers. And so it needs to know all the possible k-mers at all times. And that means it needs to basically memorize your entire file. So it can't be split up. And this is brutal. Maybe someday some computer science nerd will figure out a way of doing this where you can split it up. But right now, De Bruyne graphs are like the state of the art, and they're not parallelizable in that way. So good thought, but we're splitting it up best we can by doing 20 processes. But they still have to be able to talk to each other really well. So if this goes over our 128 gigabyte limit, we just can't do it, because that's as big as our computer is. So what can we do? Because I'm not going to take no for an answer. Good for yeah, login node only has 64. So we gotta move to Kuro. I hope it doesn't come to this, but your account, you've got a Bora account, you also have a Kuro account. And so you can log in to the Kuro login node and submit jobs to that cluster. Scratch 10 works the same, Data 10 works the same, your home works, it's all the same thing. It's just, it gives you access to a bigger computer. The reason we didn't start there is because the HPC people asked us to use Aura. It's got some more nodes. It's not under as heavy demand because it only goes up to 128. So they said for teaching, keep them on that. I was like, yeah, maybe. So this might be the point where we do have to switch to Kuro.
For like what's simple.
For any assembly. For a big file, Kuro is not enough. So if you have a metagenome that's like 5 gigabytes in size, Kuro is never going to be able to handle it. You need like a terabyte of memory for that. Where do we get that? Here's one that's 512, but that's only this one Astral node. We've got 2 nodes on Gust. Go up to 512. We've got Gulf has 2 nodes that go up to 512. There we go. So that's a terabyte of memory. The name is Grace. There's a terabyte. It was JD server 2. Those aren't ours. Those are individual labs that have purchased their own node. And so you could try to run a job there, but if they decide they want to run a job, they can. And when they submit it, it kills yours because they own it. These nodes, since I just bought 2 of them, I can tell you that they cost about $38,000 a piece right now. So great. They spent that money, so they get to kick us off. So if you do have a really big job, it's publicly available for you. You can log into the Grace cluster. But good luck getting a whole job to run for 3 days or whatever, because they're an active research group, they're going to bump you out. This is called preemption, and it's just a thing that Slurm can handle. The VIMS nodes, we do have access to these as well, but they're not that great. Let me go up to 256. So our best bet is to hope that we can get one of these 47 Kuro nodes, to run if we need it. We try Bora. In 2 days, we'll find out if it fails or not, essentially. So that's that, and then we can give it a list of K-mer sizes. We're going to leave that to be auto for now. Those must be odd numbers and less than 128. So by default, it does 21, 33, and I think 55. And what is a K-mer? You'll hear this in genomics a lot. K-mer approaches depends. It's well,
You know, like taking like helium and like amount pieces of like little fragments of nucleotides, and then like you're seeing which ones align the best, and then you're kind of finding like the optimal length that you find like the best alignment.
yeah. So a 27 mer would be every possible 27 nucleotide long word that you can spell out of whatever sequence you've got. See if I can find a nice picture. Oh yeah, Okay, so we're trying to reconstruct the original initial segment of DNA. We've got all of these short reads that our Illumina machine gave us. And this is all the possible formers. So every possible four-letter word that you can spell out of this sequence shown here. All right. So the idea is that if we have all these possible words here, we can get back to the original sequence by lining them all up and seeing how they align. There's several ways in which they can align. And so this is why it's a graph theory, because it can split into like all these thousands of options. And this is why Spades takes up so much memory, because it has to memorize every single one of those possible words for every sequence in that file. And then it has to put them all together in every possible combination, and then see which one is statistically most likely. So it's quite the process. But we can tell it what size we want those words to be. By default, it's going to look for 27 MERS, 33 MERS, and then 55 MERS. You will get a better assembly if you take it up to 127. But you will also probably never be able to run that on an HPC that goes up to only 300. That's to memorize a lot. Well, I've got some in my Scratch 10. Let's see. Scratch 10. Assembly of 8. I've got some QC files. For now, you can just work on the raw files. You can see that my QC files are a little smaller than the raw ones. Not a ton smaller, but it did dump some reads. I told FastP to get rid of any read that had a single N anywhere. I think that's the most important because N is just unknown. We can never reconstruct that, so throw it out just to be safe. So that's what making it smaller. But it's going to look, oops, don't get scripts. We've got QC, our assembly. It's also going to want to know where all these directories are. I'm going to copy that into my assemble script. And then it's going to be spades.py and then some options are in, or wait, 1, R2, and our output directory. Okay, what are those going to be? Need 1, need 2, need output. Do I tell the script what to do? Let's make this into a for loop. Or forward in some stuff to need to assign reverse reads. Need to assign an out directory. And then we need to do spades.py -- meta to and out. What should I move through?
That's good. permanent, not quickly. Like not the, what is it called, when you use like the friend. Yeah,
Yeah, I'll do that for assigning these.
and then you just.
I want to derive my reverse file and my out directory from the file name.
Yeah, and then you just set that for, right?
Yeah, I'm gonna set that for O. But what should I be looking through in the first place?
For like every like underscore one.
Yeah, these. So that's my quality control output files. But where are they?
It's like scratch and assembly of the data raw in a file.
Yeah, they're in DL underscore DIR.
Yeah, so I've already got
Oh.
a nice spot for them. So that's gonna be. Oops. My download directory. Slash. All of the files that have one underscore qc.fastq. Okay, so that right there. Oops. Is what I'll be looping through. He doesn't like that. What's wrong? Help me parse this error.
That's the fastq.dz isn't a directory, it's just like a file.
That would list all the files.
You haven't set the,
I haven't set download directory. See how this expanded into nothing.
Hmm.
So I need to run these. So I'll just copy paste them, run them. Now I'll list them and there, it found them. It's actually just one file. That's okay. Okay, so far that works. As long as these have been run, then it'll understand what download directory is and it'll find that file. And so that I'm happy with that. I'm going to copy it, paste it in here for what I'm looping through. Now I need to use that parameter expansion with replacement and turn that file into the reverse. How do I do that?
massage. And then the like. The one part, like the underscore, like star underscore one. And then we're gonna do slash and then do just like the underscore two and then.
Yeah, that should do it. As long as that thing is actually called forward, which it will be in our for loop.
Is there a reason you don't have to do like the ending of? Like, or I guess, yeah, and I just like looking at the example, you have to like the QC and you do. Like the underscore one, the dot fast food dot. Easy, like is there?
It means safer.
Okay.
So this right here would replace any underscore one that it finds, even if it's somewhere in our file name. And look, we've got some dangerous looking stuff. We've got an underscore 08 in our file path. What if we did have an underscore one there? It would replace that, putting it in completely the wrong spot that probably doesn't even exist. And so I do want to be a bit safer. QC fastq.gz. So this is restricting that match, making it really have to match the whole thing. Replace that with underscore 2 underscore qc fastq.gz. So I like this better just for safety.
is what you can.
Replace all the matches.
The first time it sees it. Yeah, so exactly the wrong thing you want. You can make it replace all of them with another flag in here. I'm gonna copy that. Put that up here. And make that. Verse equals. So we're already assigning forward up here at the top of our for loop. So that should work. And then we need to get an output directory from that inside of our loop. Hmm?
It's after, like, out, I do R.
Oh, thank you. Yes, much nicer. How do we get that?
What is like the output of spades?
The output of spades is a whole folder. Full of stuff. Yeah,
I guess it has to be like an empty figure.
yeah, we want this to be just the name of the folder, so it can be anything. But that folder will contain all of the stuff that spades outputs.
Are you able to put it in like a folder that already exists, but it's an empty folder?
Mhm.
So like, should we put it in the like the MG assembly directory?
We should. So yeah, we want it to go in here into like output or contigs or something like that. And then we don't want to lose the name of that sample. So really we want that name and all of this, except for we don't want it to be in data raw, right? We want it to be in like an output directory. How can we use parameter expansion to get essentially, I'm just going to type it out here so we know what we're looking for. I would love for out be something like that, where we're not losing the sample name. And where it's in a nice sane place in our scratch storage.
So with like, we'll have like a folder with contigs and then like a space and we're going to the like whatever folder.
In that ERR folder named after this sample, we'll have like a bunch of subdirectories in it and all of our output files. So the output of spades is not just a single file, it's like a whole directory full of stuff. Let's see, if this is our forward. Assign it to that so we can play around. Got some little tricks for our parameter expansion stuff. We've also got like their name. The directory name of forward. Gets us part of the way there.
And there's no like base name.
Here's the base name of forward. Gets us just the file name without the directories. So if we combine these two with a little like pattern replacement, we can get there. So we want the base name of forward, but without this stuff.
Is Jeremy just getting like a path like up until that directory?
Up until where the file is, yeah.
So that could be like to a directory or to a file. Cause like in the forward, oh wait, no, it is still a file.
Yeah, forward's got the whole file. Dir name won't work if you give it a directory,
Okay.
if it wants an actual file.
Is base name not what you? I thought base name like got rid of everything before the period. No, or is it just the whole thing?
It's the whole thing. So it's. I echo that process substitution. Okay, we get what we've got there. But we want to get rid of all that stuff after the first underscore, including the first underscore. So let's see. I'll make a new environment variable called file name, and it is equal to base name of forward. So it's going to evaluate what the base name of forward is and assign that to file name. Great. I like that. This is progress. I'm going to copy that down. Can't set the out directory yet. We've got to do some more enablement. So we're going to do this in a few steps. So there's the file name. And then if I echo file name, is that how you do it? Store. That's back in an old lesson. Variable then percentage.
Yeah.
All right. Right here. Oh. So like, so the variable is file name, percent underscore. Stop. Ah. All right. I like that. That right there is my sample name. I wanted to evaluate that. Let's see if we got it. Echo sample name, yes. Happy. Copy. Okay, so we're getting there a piece at a time. So we can get the file name, we can use that file name to make the sample name. That's basically going to be part of our output directory. Okay. And if I remember correctly, we've already got a download directory. So we can use project directory, $project here, and then add in contigs and our sample name. That's the output directory. So I will nano here. Config directory equals project here. / configs. Okay, mkdir config here. Then our output directory will be something like config here / sample name. So, with that. Beautiful. So we make our directory for contigs. We add in the sample name that we just derived from the file name, and suddenly we've got the perfect thing for -o in our script. Right? I'm happy with that. So adding it. This, and out here equals echo all of that. Side of the process substitution.
Why did really?
I don't think you have to. At this point, it's just enough that works.
That's fine.
I think it's like an extra step, like catting before you grab. Yeah.
Okay.
Okay, so those 3 lines there. I like them. Right, so inside of our for loop. Those. We're gonna do some stuff. We're gonna create the nice file path for reverse. Get our file name, get our sample name, use them to build our output directory, and then it's just going to be a nice straightforward. One is $forward. 2 is $reverse. Out is $out here. Number of threads will be 20. I don't think there was anything else we were going to change for spades. It's now let it kind of do its defaults. I'll add some comments. One spades. Mostly default. Oh, I did forget. I have no way of knowing, but I'm guessing that running this one sample on spades would take 24 to 48 hours. So if we had 10 samples and we're looping through them like this, not gonna happen.
How do you like pick and choose before you like, waste time on like how do you decide that like I'm gonna commit to this like style and are you just going from like individual task views and like quality and like average quality throughout them or like
Yeah, so. Wait, how do I commit to what? Like the specific
before-
options or?
or I guess like if you're about to assemble this and it's gonna take like 24 to 48 hours. Like how do you know that like that or how do you have like some like confidence that like this file is worth spending this much like compute time on it? Or do you have like any other metrics to determine that? Or you just kind of do it and then like, you see it and it's either good or bad.
Mhm. Like I don't know ahead of time how long it's gonna take, but it takes a while. I mean, you know, the forward and reverse are both over half a gig a piece. That's probably a day's worth just from experience. Um, I'm gonna ask for 2 days for this job that hopes that it finishes. And it probably will. But if I had 10 of these, there is no possible way that 2 days would be long enough to do all 10. So
What's the,
I want to treat them all the same. Let's put it that way. And so the quality control that I do on one file, I want to do on all the files. No matter what. The assembly that I do on one, I want to do them all the same so that I can compare them. Sarah, I interrupted you.
oh no, my bad, what is the T20?
Threads, 20 threads.
So you don't have to take out threads, like,
Yeah.
is that in fast food?
You could do either in FastB. It's like it lets you say dash dash threads, or I think dash dash, or just dash T. I don't remember.
So it's only a dash T, and then dash dash, like competitive.
Right. The way it usually goes for command line stuff is if the flag is longer than one character, you have to do dash dash. So that's why you can do dash T or dash dash threads. And that's because you can stack stuff like when we do LS, AHL. That's all human readable long format. It lets you just do all three. If there was actually a flag called AHL, dash dash lets it know that that's one word instead of three separate flags. Well, I think this would be ready to run. I'm gonna look over it again. We'll look through the logic and make sure it's okay. And then I'm gonna run a for loop without the spades part, just to like echo everything and make sure it looks good. Make sure those files exist and everything before I go committing 2 days to this. But I'm also kind of aware that this won't work in real life as a for loop. So work in the for loop for one sample, but what do we do? While you're thinking about that, let me save this and I'm gonna just go through. Start this for loop. Still inside the for loop. Echo forward. Echo reverse. Echo out here. One. That looks right. That looks right. Happy with that. I'm feeling pretty confident that our file name parsing is right. Now all that's left is for me to check that these exist. So I'll just try to list them. It didn't give me an error, file doesn't exist, it showed it to me. Okay, so that is there. That is there. And what about this directory? No such file or directory, that's fine. Their name of that. Contigs, right? See if that exists. Yep, it's empty. Beautiful. We don't have this directory yet, which is good. That's what Spades wants. It wants a brand new directory that lives somewhere. Okay, I'm happy. This script though, my assemble cannot be run on the login node. It needs a slurm. My pipeline is going to just run everything in order. I've asked for one task, 16 threads, 1 day. Ain't gonna cut it with this. But just for the sake of getting this going while we're in class, before we talk about the next thing, I'm going to copy that. Scripts 03. I'm going to turn this into learn script. I'm going to tell it, I want 20. I want 2 days. One task on one node. Yep. I'll send this to logs. Call it assemble test. Okay, it sets up everything. Runs my one sample in a for loop. Saved as assemble.sh, but it actually is a Slurm script, so I can sbatch it. Sbatch. Sbatch. Submit a job. Ooh, it's already running. Well, that's great. Shit, out of memory. Those are my problem, not your problem. Okay. So I'm gonna go look for it, like this output directory. Here we are. It's already made all this stuff. And there are 21, 33, 55. Those are the different K-mer steps. And it's got a pipeline state. This is how it keeps track of what it's done. It makes empty files in there. Stage 0 before start, that's completed. It's now working on stage 1, the error correction start. And it's got a nice log file. Okay, so here's the output directory. It's doing error correction and assembling in metagenomic mode. It's got my left and right reads for forward and reverse. Here's the parameters, the K-mer values, it auto-found those. Temporary files go here. Memory limit, and then it started. Error correction started. It is running this particular little module. And there it goes, doing its thing. It also keeps a nice little timestamp for every step, so you can see how long it's taking.
How did it optimize like camera length so quickly? Is it like not?
It looks and sees how long your reads are and how many of them.
So you didn't have to set up like your environment have to be strict, like saying which base is that?
No, because this is my path. Good point. If it wasn't in my path, then yeah, I'd have to do that. Still doing stuff, maybe. Okay, it didn't fail or anything, it's running. Cool. Okay, so that is running. I wouldn't expect it to be done anytime soon. But when it is finished, it'll have one more file or two more files in here, but the one we care about will just be called contigs.fasta. That's it.
Not for yes, but.
Oh, yeah, yeah. Yeah, I can do that. So. Yeah. So with the caveat that this won't work for the actual assignment, because you're gonna be running multiple. I'll copy this.
How are we gonna? Run the, maybe it's up to me.
That's what I would love to talk about now, while this is running in the background. There we go. Don't copy this completely because then you'll be emailing me. I will take revenge. I'll set up a job that submits one job every second to email you curse words or something. All right. Yeah, so what do we do? This is this sample could take 2 days or it could take 3, and we don't even have enough time here. It could run out of memory on this node. But we've got 10 samples coming down the pipeline. What do we do?
You just have to submit like 10 jobs.
That's it.
You get a job that submits jobs.
We have to have a job that submits jobs. It's getting pretty meta. Right. Well, it's metagenomics, so yeah. Yeah, we need to essentially make a job that submits jobs. And so each sample gets its own Slurm job. And I do not want to or expect you to want to have to write out manually kind of those scripts. But we could make a for loop or a while read loop, which we haven't seen yet, that could go through a list of accession numbers and basically run the pipeline for that accession number. Making a little Slurm script and then submitting it.
So if there's like 10 samples, we have to have 10 like boxes for our phone.
And boxes.
Like, you know, like in Dora, how you get like this.
Yeah, you have to have 10. And when on the new S account, you can see that I've got this job running at the same time as this job. Each one of these is a sample. Now I submitted them. Okay, they're all running. As of yesterday afternoon, I had 30 of these things going. Just some of them are waiting, some are running, but they're all submitted. So that's kind of what's going to happen here is, yeah, we're going to be asking for 10 nodes. It may run all 10 of them at the same time for us, or it may give us, you can have 4 right now. There's a bunch of people in line. Your other 6 are just kind of waiting their turn. But they each get 2 days and they each get X amount of memory and they'll run when they run. Okay, so a job that submits jobs. How could we, this is a lot to think about. Like all the moving pieces in your head kind of have to be there. So let's maybe try to write it down so we can stay somewhat sane. We want a script that builds and submits Slurm jobs. Okay, right now, we have an overall pipeline. It runs setup, download, quality control. These two, they don't have to be done multiple times, just the once. Okay. So really, it's just going to be this stuff that has to be done multiple times. But to stay sane, let's just think about this assembly script. Let's assume that it's the only thing we're going to be doing. You want to write a job that writes jobs.
So like if we're running like the actual full pipeline, like for this example, if the assembly could take like up to 2 days, and like how do you like run like the other parts of it, like that, yeah.
Yeah. Good question.
Like are you able to like pick you're able to certain things or just anything?
Not very easily.
You can't with space, though, I don't have that.
You can with spades, but you can't like with this pipeline, like if quality control fails, the whole job fails. So we can go to snake make, but that doesn't play well with Slurm. It can, but no, it can't play well. It can play with Slurm, but poorly and fragilely. Next flow does better. Working with Slurm.
I don't know if you can resume.
Not in the same way you can with snake make. So what do we do?
How do you do it when you batch?
I don't want to just tell you. I want you to. I want to talk through this and think about it. Yeah. You know, eventually I'll tell you.
You do it so that like every time that like I would assume that you wouldn't want to batch like multiple at the same time. So like we just want to use like 20 cores at a time. Right, like for our whole job. Could you batch this into like once your hypothetical file path for like the FASTQ exists, that's when you batch the next job. And then if the pipeline fails.
See, that's a bit tricky. I see what you're saying. Like you could have a process going that's just like waiting for that file to exist.
Yeah.
And then when it comes into being, it submits that job.
Yeah.
That requires you to be online that whole time. If your internet connection drops out, it's over. So, yeah.
Which really doesn't come to it. They're in between the scripts and the statements of this doesn't end.
Yeah, so we can do if statements and we can do like this and. We saw that in the beginning of class, but didn't really talk about it. It means only run the thing on the right if the thing on the left gives a non-error. It completes correctly. So we can say echo hi mom and echo it worked. Since the thing on the left completed successfully, it executed the thing on the right. So we can do that kind of thing. And we can do if statements that's like if this step is finished, then do that. Or if this file path already exists, skip the download. Okay. That's where I would start with this. If I wanted this to be one pipeline, and I'm not saying that's where we will wind up, but I would say if these files are already downloaded, then don't run the first two scripts. So that way it's just skipping them every time. And then all that's left is we need to find a way to write 10 different assemble scripts or slurm jobs. Okay. Between now and next class period, have a chat with GPT. And you can kind of explain what you're looking for now. Script that writes slurm scripts and submits them. And one thing I found is that you can add a replace me statement in there. So just the word replace me. Scripts, free, assemble. Here we're doing it in a for loop, assigning forward for that. I could say, or replace me. And then I can use said to replace the word replace me with the actual accession number. We'll talk it through on Thursday, but
No, didn't you say so?
yeah,
Those are the own language, it's like, that's its own language.
we did search and replace with said.
Okay.
Yeah. Well, see what GPT gives you. Come up with a solution. And we'll chat through and see who's got like the best one. This is how I wound up doing it, is I built a template. I had that template, you said to replace me with an accession number. Write it to a new file and submit it. Let's see what you get. Thank you. Time flies, it's fast.